Hello, 10th graders. It is Miss Mariah Day, and I am doing a little video for your lesson this week. Know that now, between now and the end of the school year, I'm going to do my best to at least give a little video, whether the video is a hello or the video is a lesson that I'm presenting for you. So in today's lesson is going to be a follow-up of the lesson on the reading that you did a couple of weeks ago. Instead of going on about the protein myth, what we are going to do is on that second page, as you read on the second page, you saw a little bit about why you really need proteins, and you also read about that there are 9 essential amino acids that we get from food because our bodies aren't going to produce these essential amino acids that we need in order to survive. So there are 3 on this page, and then there are an additional 6 on the other page. As you're watching this video today, I'm going to ask you to be taking notes. So that's your main task this week, is to follow along with the video, take notes, and when you're done, please take a picture of your notes and upload them, or scan your notes and upload them to the Google Classroom assignment. So if you have any questions, please send me a message on the Remind, or send me a message on Google Classroom, or email me. Any of those things, you can get in touch with me. I hope you have a fabulous week, and we will be in touch. All right, students, as we get ready for the notes for drawing the structural formula for these 9 essential amino acids, what I'm going to ask for you is just to kind of remember, you don't need to rewrite or bring this even back up, is that when you did this reading, you read about the 9 essential amino acids that we are going to sketch. So we're going to start out with histidine, leucine, tryptophan, valine, threonine, lysine, methionine, isoleucine, and phenylalanine. So know that as we're drawing these, please pause your video if you feel like the video is going too fast to get caught up. So as you might see already in my paper, it's a little bit blurry, so there we go, it's getting more focused. I'm going to start out with histidine. On your paper, you don't need to have this much space between each one. I do recommend, however, like maybe having 4-finger widths between each one. I made it a little bit larger because of the video. So as you're watching, I strongly encourage you to pause and then kind of fill in as you go. So I'm going to do what we call the backbone and the central atom for each one of these 9 essential amino acids that we are going to draw. So to start out with, I'm going to start out with histidine. So I'm going to zoom in here a little bit, histidine. So I'm going to start out with histidine. Going to have what we call the central carbon. Remembering that honk 1, 2, 3, 4 rule that we learned last year. We've got carbon with 4 bonds. On the very top, I'm going to put a hydrogen. On the left side, I'm going to put a H2N. Yes, that is an H2N, the same thing as writing NH2, but this is again remembering that honk 1, 2, 3, 4 rule, that the nitrogen has 3 bonds. It has 1 to the carbon and then 2 hydrogens on each side. And then on this side, on the right side, we're going to do a COOH. If you remember from a couple units ago, the COOH is going to be what? So think about it for a brief moment. Remembering that this is actually going to be a carboxylic acid. So remembering a carboxylic acid is a carbon with a double bonded oxygen and an OH. So that would be what that is going to represent once we get into there. And for right now, I'm going to actually leave on this central carbon, I'm going to leave this bond empty because that's where we're going to come in and we're going to do the rest of what we call the R groups. So every single one of these amino acids has this structure, has this backbone. So I'm going to go ahead again with leucine. I'm going to start with carbon. Going to give myself a hydrogen at the top. The right side, I'm going to COOH, then a H2N. I'm going to go down here. Tryptophan, going to have the same thing. carbon, COOH. You can do it in any order that you would like. So, oh, I didn't underline our tryptophan there. Then I've got a H2N with a bond coming off that central. Valine has the same backbone, same central carbon. I'm gonna have the H2N. So for lack of time, or for sake of time, go ahead and pause your video and do that for the rest of these amino acids that we are going to draw. All right, so you will notice that I have gone ahead and done all of these backbones for each one of these 9 amino acids. I've also highlighted them to highlight the fact that they all have these things in common, because as we end up drawing each one of these amino acids, you're gonna notice that this bond that's coming off of here is what's gonna be the difference between each one. So if I was to draw our basic backbone for an amino acid, it would look something, again, here we go, taking a quick glance at this. We got the carbon, we got the COOH, we got the NH2N, and then remembering that R group. Remember, R represents, we like to call it the rest of the molecule. So we're going to draw the rest of the molecule for each one of these. Please bear with me. This first one is one of the more complex ones. So I am going to do it without, you could essentially, whenever I give you a carbon, you could do the lines for your own, but you're going to see me write CH2 in this case. I strongly suggest that you start transitioning your brain to write this instead of just the lines for your own reference, because you're going to see most of your references for the rest of this unit and the rest of the year to have the CH2 versus just the 2 lines, even though you might know that it has the 2 lines in it. So the 2 lines mean 2 hydrogens. So to start out with, this histidine, I'm going to zoom in a little bit more for you. Here we go. Got a CH2 is going to come off the bottom there. Then off of that CH2, we're going to have a carbon. And we're going to have a 5-membered ring off of this into this carbon. So the way I'm going to draw it is to the right. I'm going to do a nitrogen. That's going to be one of the members of the ring. From the nitrogen is going to be a carbon. Then there's another nitrogen. Then there's a carbon, and there's our 5-member ring. So we're still not quite done with this, remembering that nitrogen needs to have 3 bonds. So nitrogen is going to have an NH. This carbon is going to have a CH, but in order to account for, again, it has only 3 bonds for this carbon, we need a 4th, so it's going to actually have a double bond with that nitrogen. That nitrogen now has its 3 bonds. This carbon only has 2, so this one is actually going to have an H, and it also has a double bond. So this right here is histidine. At the end of the video, I'm going to give you a couple ways to remember each of these amino acids and their structure. So for now, we're just going to focus on drawing each structure, and then probably as I'm drawing, I'll give you some of the clues that have been shared with me, and then some that I've thought of on my own. So moving on, we're moving to leucine now. So leucine, significantly easier than than histidine. So leucine, similar to histidine, we're going to start off with a CH2 coming off. From that CH2, we're going to have a CH. Off of that CH, we're going to have what we call 2 methyl groups. And notice I'm going to do H3C, because that then shows that that carbon is attached to that. Here, if I wrote CH3, it could kind of start to look like the hydrogen is attached here. So this carbon has 3 bonds, and there it's 4th. And that's leucine. See the difference between histidine and leucine. Leucine is significantly easier. One way that I remembered whenever I was in college learning about biochemistry is that leucine sounds like losing, so I think of leucine is losing my mind. I don't know. Again, you're gonna be, what? Just really, I'm thinking of this as being my mind, and my mind is getting dropped down here. You can think that my ways are very weird. Know that you can probably think of ways to remember why this structure is leucine. Then I'm going to move on now to tryptophan. Tryptophan is considered to be a little bit more complex, so in this case I'm actually going to zoom out a little bit. Tryptophan is literally the largest one that you need to be familiar with. Tryptophan, if you've heard of it before, tryptophan is if you ever have turkey usually during Thanksgiving, tryptophan is the amino acid that makes you feel sleepy. So that is in turkey. So just like leucine and histidine, tryptophan is going to start off with a CH2. Off that CH2, we're going to do another 5-member ring, just like histidine, but instead of those there's only one nitrogen this time. It's going to start out with a carbon. Then off of that carbon, it's going to be another one. Then here's where our nitrogen is going to go. And then we're going to have some carbons around here. So that's going to be what you're going to see for tryptophan. We still need to move in and add one more ring here in a moment, but then also fill in our bonds. So we've got this carbon has 3 bonds. This one's going to do a double bond. This carbon still needs another bond, so in this case it's going to have a hydrogen. Nitrogen has 2, so this one is actually going to have a hydrogen. This carbon right here, this is where it's going to get a little bit funky. So notice this carbon has its 4, this carbon has 2, this carbon has 2. This carbon is going to double bond, but then each one of these carbons, I'm going to go down a little bit, is going to have, this is where the 6-member ring starts. So we have 1, 2, 3, 4 from here. We then have a 6-member ring. Between every other one, we have a double bond here. We're going to have another double bond there and another double bond there. Each one of these carbons that are attached here only have 3 carbons. So, 3 bonds. So each one of these carbons here has a hydrogen. Know that you often will sometimes see, this is called a phenyl group. This specific, just this 6-member ring in biochemistry and organic chemistry, you'll see this sketched in many different ways. One way that you'll actually often see it, the quick route, in order to draw this, you'll often see it like that. So that'll be another way you'll often see it. Know that this circle essentially is meaning that that double bond is rotating around, because there's never any case that there's just this double bond here. The double bond actually travels in this ring between each one. So that one is tryptophan. I'll share with you later on one way to remember about tryptophan. Moving on to an easier one, we got valine. Again, remember, please pause your video as you need to get caught up on, to be able to draw some of this. So then we got valine. Valine has this one. Notice each one had CH2. Valine actually only has a CH. And then off of that CH is going to be a CH3 and another CH3, so 2 methyl groups. This one, a quick one, I'm just going to give it to you now. Valine actually kind of makes this upside down V shape. So if I was to do an upside down V shape, it kind of looks like V, and valine is the only one. So turning this upside down. So upside down V for valine. So that's one way to remember valine. So again, that's one way to keep going. So we're going to keep on going. So if you have already written this, excellent. Go ahead and keep going on your video. We are now going to go to threonine or threonine. So valine and threonine are going to be very similar. I'm going to put them side by side here so you can kind of see. So threonine, also a CH, also a methyl group, but instead of having another methyl group on the left side, it's actually going to have an OH group. So it's going to have that alcohol group just like we learned earlier this year. So one way to remember the difference between valine and threonine is, see we have this O. I'm going to again share with you one quick way to remember threonine. O, 3-O-nine. So 3-O, this, I know this is ho, but you could also say backwards O. So this is also an OH group. So 3-O-nine. That's, again, one way I remembered. Moving forward to lysine. So lysine you might have heard of before if you or anyone you know has herpes on their mouth. This is one of the medications that they prescribe to help you get rid of any kind of breakout. So lysine is one that we are going to draw here. So lysine is going to be a CH2, just like the ones we learned about earlier, but then check this out. It's going to be 4 CH2s. There we go, CH2, but then at the bottom of that CH2, we're going to have a NH2. And that's lysine. Lysine's a little bit easier than some of the other ones. So CH2, 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 and 4 CH2s, and then an NH2 at the bottom. I had a student actually share with me their way that they were remembering lysine is they kind of imagine lysine being like a little insect. So it's like kind of like a centipede, but then they thought insects like lice. So again, I decided to kind of share some of the ways to remember how to remember the name associated with the structure. So what we call the mnemonic device. So that was my student's suggestion, which I think is a really great way. So lysine has this long chain of CH2s like a centipede, and then thinking about insects like the insect of lice. All right, so then methionine. Methionine is gonna be similar to the rest of, so threonine and valine and are gonna be the ones that have just the CH, but methionine is gonna have that CH2, it's gonna have another CH2, but it's one of the very few, it's the only one in our essentials that has a sulfur. So then it has a sulfur, and then coming off that sulfur is a CH3. So you got a sulfur group, a methyl group at the end. So one way that, again, I decided to just share out your mnemonic devices as we're going. Methionine, if you think about methane gas is what we use in the Bunsen burner. We ignite the methane gas, it stinks. So stinky S, methionine is the only one that has a sulfur. So, and sulfur is stinky, the letter S. So that is one way to remember methionine. Moving on to isoleucine. Earlier we had leucine. Thinking back the second one that we drew, we had leucine right here. Now we're doing isoleucine. So to kind of be able to help you see the difference between these two as I'm drawing isoleucine. So we have, here we go. So again, we're going to start out with that CH2. Then we're going to come down to a CH. From that CH, we're going to have, just like with leucine, we're going to have a methyl group on the right. But instead of having a methyl group like a methyl group on the left side, we're going to have an ethyl group. So we're going to have a CH2 and then a CH3. And there we have isoleucine. So leucine and isoleucine look similar. Isoleucine. So isoleucine is a longer word, so it's going to have that longer chain. So this one was, again, I know it's a far stretch saying losing my mind. But again, that was a mnemonic device that helped me. Maybe it'll help you. Isoleucine has that extra little, the ethyl group. So it's a little bit longer, like it's a longer word than leucine. And then we are already at our last one. So as we do this last one, I want you to remember when we drew tryptophan, I'm gonna zoom out a little bit. When we drew tryptophan, we had this 6-membered ring. So that's really what phenylalanine is going to have. That we're going to start out with that CH2. And then just like tryptophan had that 6-membered ring, phenylalanine is going to have that too. So we've got 1, 2, 3, 4, 5, and 6. There's our 6-membered ring. Remembering every other carbon is going to have a double bond. And a double bond. This carbon is not going to get a hydrogen because it's attached here, but the one next to it, every single one around, is going to have a hydrogen. And that is phenylalanine. So as I mentioned before, I've already kind of shared a couple of the mnemonic devices to remember. Phenylalanine, tryptophan, and histidine are the 3 that have your ring structures. So I don't have any fun mnemonic device to remember histidine, but tryptophan, this is one of the things that whenever I was in college, so that I remembered, is I imagined that these were 2 actual fans, like a fan in your living room whenever it's summertime, going around and around, and there's 2 of them, so I tripped over the fan, tryptophan. I had another student that said tryptophan is one of the longer words, and it's also the bigger molecule. And then phenylalanine, this is considered to be a phenyl group, so that's really not going to do you much help because we haven't learned that in class. So that is your 9 essential amino acids. I'm going to share, at the end of this video, I'm going to share one other little thing to remember each one of these names. So my thought to you is know that I'm not going to ever expect you in this class at this point, in the time that we have, to memorize be able to draw all 9 of these, but I would expect you to be able to recognize them. So if I showed you a picture of leucine, that you would then be able to know that that is leucine, be able to differentiate between leucine and tryptophan, being able to differentiate between leucine and isoleucine. So being familiar with those is one of the essential parts of this unit. So if you have any questions, please feel free to send me an email or send me a remind message, any of those things to kind of get you set up. So that was your assignment, to take those notes.